Hi guys, welcome to this video in which we are going to learn some fundamental concepts of circuit theory. In this video we will learn about Ohm's law and behavior of resistors in series and parallel circuit. The learning objectives of this video are to introduce Ohm's law and to analyze the behavior of resistors in series and parallel circuit. The learning technique adopted for this video is learning by analogy. Learning by analogy means comparing the new idea with an existing idea so that we can easily understand that. Okay, now look at the picture on the screen. You can see that there are two tanks, tank A and tank B, connected using a pipe. So you can also observe that the level of tank A is higher compared to the level of tank B. Since there is a pressure difference because of the level difference of the water, we can easily understand that the water will always flow from tank A to tank B through this pipe. A similar situation is present in electronic circuits also. This is first observed by George Simon Ohm. George Simon Ohm, you can see George Simon Ohm on the screen. He is a German physicist. He observed that in any conductor, if we provide a potential difference, here you can see a battery is connected to provide the potential difference. If we provide a potential difference, the electrons will flow from negative terminal of the battery to the positive terminal of the battery through the conductor. Since the conventional current flow is considered opposite to the flow of electrons, we have shown the current flow in the opposite direction, that is from positive terminal to negative terminal. That means if there is a potential difference across the two ends of a conductor, there will be a current flow through the conductor. So Ohm's law states that at constant physical conditions, the current flowing through a conductor is directly proportional to the potential difference across the conductor. So we can mathematically represent it like the current I flowing through the conductor is directly proportional to the potential difference across the conductor. So we can remove this proportionality constant by writing I is equal to V by R. That is, there is something which is inversely proportional to the current flow through the conductor. That is nothing but resistance. So we can write the equation I, current, is equal to V by R, where V is the voltage or potential difference across the conductor, R is the resistance across the conductor. So this is the famous relation we can get from the Ohm's law. Now consider a situation in which we need to purposefully control the flow of water. In that case, we need to use something like this, a gate valve. I hope you have seen this kind of gate valve in the water pipe connection systems at your home. So I have represented a gate valve using a T symbol here. So a similar situation arises in electronic circuits also, where in which we need to control the flow of current, that is purposefully control the flow of current. In that case, we are using a device called resistor. I have shown the symbol of resistor here. The letter R is used to denote the resistor and its unit is ohm and it is denoted using the letter omega. So when we connect a resistor in a circuit, it will oppose the flow of electrons. That is why we gave the name resistor, because it is resisting the flow of current. Okay, now consider a situation in which you can see that the pipe connecting tank A and tank B is connected with three gate valves. So these kind of connections are called series connection, because the gate valves, you can see that the gate valve is connected one by one and there is only a single water flow through this pipe. Consider we are connecting the gate valves one by one. So if you are connecting the first gate valve, you can see that the water flow will be reduced a little, and if you are connecting the second gate valve, again the speed of the water flow will be reduced, and if you are connecting the third gate valve, again the speed of the water flow will be reduced. So each gate valve has its own contribution towards reducing the speed of the water flow in the pipe. So similarly, what happens if you are connecting three resistors R1, R2 and R3 in a circuit as shown here. So this kind of circuit is not a series circuit because they are connected one after another, and you can see that there is only one current flowing through this circuit and the supply voltage provided is denoted using the letter Vs. Okay, now let us analyze what will be the effective resistance or total resistance of this circuit. How can we analyze that? So we can see that the total voltage Vs, subscript S is denoting series connection. So Vs is equal to V1 is nothing but the voltage drop across the resistor R1, that is V1, plus V2 is nothing but the voltage drop across the resistor R2 plus V3. So V3 is the voltage drop across the resistor R3. So the total voltage will be dropped across the resistors R1 and R2 and R3. That means each resistor has its own contribution towards dropping the voltage, total voltage. So we can write the equation Vs is equal to V1 plus V2 plus V3. So what is Vs? From Ohm's law we have seen that I is equal to V by R. So we can write the relation like V is equal to I into R. So in that case we can write Vs is equal to I into Rs. So Rs is the total resistance, effective resistance. We don't know that actually. So I into Rs is equal to V1. How can we write V1? V1 can be written as I into R1 because R1 resistor is creating the voltage drop V1 plus I into R2 where R2 resistor is creating the voltage drop V2 plus I into R3. So how can we simplify it? I into Rs is equal to, we can take I common, so we can write R1 plus R2 plus R3, and if we cancel I from both the sides we can write Rs is equal to R1 plus R2 plus R3. So what this equation says? This equation says the total resistance due to series connection of resistors. That is why Rs is equal to R1 plus R2 plus R3. That is the total resistance in a series circuit is equal to the sum of the individual resistance values. Now look at this picture. Here you can see that there is the same tank A and tank B. Instead of one pipe you can see that there are three pipes, and in each pipe you can see that there are gate valves 1, 2 and 3. And these kind of connections are known as parallel connections because they are connected parallelly, not one after another. They are connected parallelly. You can see that all the pipes are connected to the same ends. It is coming to a common end, so the potential difference, the pressure difference experienced by all the pipes are same. But there are three flows, water flows. This is one water flow, this is another water flow, and this is another water. There are three different water currents present in this pipe system. The pressure difference experienced by all the pipes are same. So similar kind of circuit can be seen in electronic circuit also. That kind of circuit is known as a parallel circuit. You can see that there is a circuit, there is a potential difference, there is a battery connected here and split into three paths, and in each path you can see resistors R1, R2 and R3. These kind of connections are known as parallel connections. You can see that the three branches are connected to a common point, that is the potential difference across the resistors are same. We can see that there are three currents flowing through these three different branches, that is I1, let us say I1, I2 and I3. And let us try to find out what is the effective resistance, what is the total resistance of this circuit. Consider because of this battery a current I is coming into this circuit, and we can write an equation I is the total current, that is equal to I1 plus I2 plus I3, because the currents are divided into three different parts, different branches. So we can say I1, I2 and I3. So I1 is the current when current passes, the electrons pass through the resistor R1 branch, and I2 is the current when electrons passes through the R2 branch, and I3 is the current when the electrons passes through the R3 branch. We can from Ohm's law we have the equation I is equal to V by R. So we can write Vp is the total potential difference of the circuit, Vp by Rp, where Rp represents the resistance, total resistance in the parallel circuit. We don't know what is that actually. So that is the total current. The current is given by the voltage divided by the total resistance, which is equal to I1. What is I1? I1 is given by again Vp divided by R1, because I1 current is due to the flow of electrons to the resistor branch R1. So we can write I2 is equal to Vp by R2 plus I3 is equal to Vp by R3. Taking Vp common, we can write like Vp by Rp is equal to to Vp into 1 by R1 plus 1 by R2 plus 1 by R3. So if you cancel Vp from both the sides, you can see that you will get an equation like 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is an important equation. What this equation says is the reciprocal of the total resistance in a parallel circuit is equal to the sum of the reciprocals of the individual resistors. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3.